Okay, this is 5.3 slope-intercept form. It's muy importante. If you don't know your Spanish, that means very important. Okay? Muy importante. All right. First thing, what is slope-intercept form? So let me write that really big. So it's y equals mx plus b. It's a certain way to write an equation of a line. So whoops, didn't want that. Okay, the m is always going to be the slope, and the b is always going to be the y-intercept, which means that's where the line crosses the y-axis. Okay? So those are the two things. Whenever you want to write an equation in slope-intercept form, you always need the slope and you need the y-intercept. That's why they call it slope-intercept form, for that reason, because of those two key things, two key numbers that you plug in. Now the x and the y change a lot, because as you graph a line that the x's and the y's are always changing, but the things that don't change are the slope, because the slope would stay the same, and the b would stay the same because it would cross, the y-axis in a particular spot, and those things will not change. Okay, so that's why the x and y, are really considered the variables, if you will, once you have established, what the m and the b are. All right. There are 4 things that we need to be able to do out of this section, and they're not too difficult, at least most of them. We want to write an equation in slope-intercept form. This is the easiest of them all. If they give you, let's say they give you the slope. So they say the slope is 3. Slope is 3, and they say the y-intercept, sometimes we'll say y-int, y-intercept is 5. Now they've really given us the 2 things that we need to be able to write an equation in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. We only have 2 things to plug in, the slope and the b being the y-intercept. So the m is right here, it's 3. The b is 5, so we just write our equation. Y equals 3x plus 5. That's it. Just plug those 2 numbers in. Part B, same thing. We could just give it to you in a different way. We might say, we might come right out and say m equals 1/2, and we might say b equals -2. Well, same thing. You just write the equation. Right? Y equals, now the m is just, again, the number that goes right in front of the x, so that's 1/2 x, and then the b, it's always going to be plus b. So if the b is already negative, then we'll just say -2. And that's slope-intercept form, plugging in the m and the b, the slope and the y-intercept. Part C, just give you another answer. We'll say, hey, the slope is -3, and let's say the y-intercept is 0. Okay, no big deal. We will say y equals, and the slope being -3, we'll just put -3 right in front of the x, and then the b is 0, so we can just say plus 0, or not write that. So our really the best answer would be y equals -3x. We don't really need to put that plus 0. That doesn't do anything. Okay? So, and this looks very familiar. This looks like the direct variation equations, y equals kx. So if the b is 0, then it really becomes like a direct variation equation, y equals kx. K kind of being the slope here. Okay? That's the first thing you need to be able to do. Next thing, you need to be able to graph lines. So we have a line that is y equals -2/3 x and +1. Now, slope-intercept form is the absolute fastest way to graph lines, better than what we did in the last chapter, where we made a little XY table and we plugged in values. That's a good way to do it. I mean, it always works, But for this problem, wow, that'd be really a pain, trying to figure out what number to plug in so that this answer would come out well because it's a fraction. What a pain that'd be. So we don't want to do that. So the way you do all these is you start with the y-intercept. So you put a dot. If it says the y-intercept right here, look where it's at the b. So that means we go up to the y-axis. This is the y-axis. So it says that the y-intercept is 1, so we just put a dot right here at 1. Then we look at the slope, and we can see the slope is right in front of the x. So that means it's negative 2/3. That's the slope, which is the rise over the run. So that means, according to this slope, we're supposed to go down 2 and over 3. So we start at the y-intercept. We go down 1, we go down 2, we go down 2, and we go over 3. Down 2, over 3, connect the dots. There's your line. That is absolutely the quickest way to graph a line. So to repeat, start with your y-intercept, put a dot. You do whatever the slope says to do. Slope says down 2 over 3. Now it is really interesting where your negative sign is, because it's possible that someone could have thought, oh, you know what, the negative sign is actually on the bottom. Okay, that's interesting. So this time we'll still start at the y-intercept, because you always have to start there. But now the 2 is positive, so that means we would go up 2, because it's a positive rise. So we go up 2, and then the run is negative, so then we would go over 3, and we actually would be able to connect the dots and be on the same line. Exact same thing. Or you can put the negative sign out in front, but you kind of have to make a decision when you use the slope, whether it's on the top or the bottom. Just don't put it on the top and the bottom, because then it will not be the same line. Because when you divide two negatives, then it's actually a positive, and you will get a different answer then. All right, let's try another one. Let's say y equals 3x minus 2. So what we do is we start with the y-intercept. So you look at that and you say, okay, looks like the y-intercept is negative 2. So that means it crosses the y-axis at negative 2. You put a nice dot there. And then you look at the number that's in front of the x. That's always your slope. So we would say the slope is 3, right? So slope equals 3. But it's really helpful if you can always write your slope as a fraction so that you can tell how much your rise is and how much your run is. So we put it over 1, and that means that's our rise over our run. So we start at negative 2, and our rise is 3. So we go from this point, we go 1, 2, 3. We run over 1 unit. We connect the dots. There's your line. That is absolutely the quickest way to graph lines. Way quicker than making an XY table. Of course, if we make an XY table, it would work. Plug in 0, we get negative 2. Plug in 1, we get 1. We end up with all the same points, but this is just quicker. All right. Third thing you need to be able to do, and maybe this one's the hardest for people, is to try to write equations in slope-intercept form when they're not in slope-intercept form. It is helpful to write them in slope-intercept form because then you can graph them so quickly. Okay? So, slope-intercept form, y equals mx plus b. So we just manipulate. I would say this goes back to section 3.8. And I think I even made a video of that. We were starting our videos then. So 3.8, solving for a particular variable. When we're trying to put it in slope-intercept form, we're trying to solve for y, because we want to get the y by itself. So we need to get rid of everything else. So we need to get rid of this. Right now we look and we see it doesn't have a sign on it, so it's positive. So we're going to subtract 5x from each side. Now when we do that, of course, those are opposites, so that's going to be gone. And we'd be left with negative 3y equals. Now, these are not the same, 6 and negative 5x, so please do not combine those. They're not like terms. So I'm going to say negative 5x plus 6. You might say y plus 6. Well, because it's a positive 6, so you do add those together. Why did I put the negative 5x first? Well, because we want it to look like this, and it looks like the x is before the number, so we need to put it in that form. It is the exact same thing mathematically as 6 minus 5x, but this is a better form. Now we're solving for y, so we need to get rid of this negative 3. So we're going to divide. It's being multiplied, so we divide by negative 3. Divide by negative 3. That cancels out. We're left with y all by itself. Then we do what we've kind of done before, where we do a little dividing. We take this part and we divide it. So it looks like a negative and a negative. So that's a positive 5/3 x. And then we actually need to divide these numbers. So that's 6 divided by negative 3. So that is, what is 6 divided by negative 3? Tell me you said it was negative 2. So there. Slope-intercept form. Again, it would be super quick to graph. I mean, I can graph these so quickly, and you will be able to too. Go down to negative 2, put a dot. The slope's 5/3. You go 1, 2, 3, 4, 5 over 3. There's your line. So quick. That'd be a pain in the butt with an XY table, trying to come up with values that work with 5/3. Who wants to do that? No one. Okay. Same exact deal. I just wanted to do another one of these where you're trying to get in slope-intercept form. So again, we're trying to get the y by itself. So got to get rid of the 5x. It's positive. So subtract it. So we subtract 5x, and that'll get rid of it, and that'll leave us with 4y. So 4y equals negative 5x plus 8. And then we need to get rid of that 4, because again, we're trying to get the y by itself. So we divide. It's being multiplied. We divide. So we divide by 4, and we get y equals, looks like negative 5 divided by 4. So let's say negative 5/4 x, and then 8 divided by 4. So that's going to be 2. There you go. Slope-intercept form. Could be super quick to graph. Super duper quick. We don't have to graph it on this one, but hey, I graph quickly with this form. Go up to 2. We go down 5 over 4. They're quick to graph. Okay? I want you to see that slope-intercept form is the way to go. Last thing we need to be able to do. We need to be able to write an equation to model like real world things, you know, like for example, cost. So we want to represent cost. So let's say C is the cost. So we don't always use X's and Y's, you know. I mean, we use whatever letters make sense. So C makes sense for cost. So C equals, and you know, you've rented bicycles at the beach. You know they cost a little bit of money. They charge you maybe a little bit just for renting it, and then a little more per hour. So let's say it's $20, and that's kind of a lot, but $20 and then plus 5 more an hour. So this would be 20 plus, and then it would be $5 for every hour that you rented it. Wouldn't that make sense? Very similar to our gym membership. This $20 is very much like the initiation fee, so no different there. Okay, we haven't talked about it exactly, but this number right here is now your y-intercept. So whatever that fee is that you have to pay, even if you don't rent the bike or whatever. So whenever x is 0, this is your y-intercept, that number. Okay, so if your flat fee or your initiation fee is your y-intercept. All right, what about the auto repair shop that rips you off all the time, or rips off your parents if you don't have a good mechanic? So you would say C equals, and it looks like we always have to pay $50, so that's 50 plus, and you got to pay $25 every single hour. And we're letting x equal hours, by the way, so I can make a note of that. I'm letting x equal the number of hours. Okay, so there you go, 50 plus 25x. That'll get you the cost for any number of hours of, you know, whatever your car needs fixing. Should be good on 5.3. Make sure you're good on all 4 of those skills.